Hello, my name is Bharat Bhusa. Today I am going to present principles of graphic systems. First, in display devices, we are going to discuss about cathode ray tube and its architecture. The cathode ray tube is a vacuum tube containing an electron gun and a fluorescent screen with internal and external means to accelerate and deflect the electron beam. Use it to create images in the form of light emitted from the fluorescent screen. The images may represent electrical waveforms, pictures, radar targets, and others. How does a CRT work and what does it display? Basically, CRT consists of four major components: an electron gun, focusing and accelerating anodes, horizontal and vertical deflection plates, evacuated glass envelope. The function of an electron gun is to produce a beam of electrons. Focusing and accelerating anodes are used to produce a narrow and sharp beam of electrons. Horizontal and vertical deflection plates are used to control the path of beam. Evacuated glass envelope is made with a phosphorescent screen which produces bright spot when struck by a high velocity electron beam. Working of CRT. Heater element is energized by alternating current to obtain high emission of electron from the cathode. Control grid is biased negative with respect to cathode. It controls the density of electron beam to focus the electron beam on the screen. The focusing anode operates at a potential of 1200 volts and accelerating anode at 2000 volts to accelerate the electron beam. Two pair of deflection plates provided in the CRT. These deflection plates are mounted at right angles to each other to provide electron beam deflection along vertical and horizontal axis of the screen. The screen consists of a glass which is coated by some fluorescent material like zinc silicate, which is semi-transparent phosphorus substance. When high velocity electron beam hits the phosphorescent screen, the light emits from it. The property of phosphor to emit light when its atoms are excited is called fluorescence. Basic applications of a CRT are: they are used in cathode ray oscilloscope, display devices in radar, in televisions, in computer monitors. Now we are going to learn about phosphor type and persistence. Various phosphors are available depending upon the needs of measurement or display application. The brightness, color, and persistence of the illumination depends upon the type of phosphor used on the CRT screen. Phosphors are available with persistence ranging from less than 1 microsecond to several seconds. For visual observation of brief transient events, a long persistence phosphor may be desirable. For events which are fast and repetitive or of high frequency, a short persistence phosphor is generally preferable. Now we are going to deal with refreshing rate and flickering. Refreshing rate is the number of times in a second that a display hardware updates its buffer. Flicker is a visible fading occurring on CRTs when they are driven at a low refresh rate, allowing the brightness to drop for several intervals successfully long to be noticed by a human eye. Generally, increasing the refresh rate decreases the flickering on a CRT, thereby reducing the eye strain. Now, we are going to learn about fluorescence and phosphorescence. A phosphor is a substance that exhibits the phenomenon of luminescence, which includes both phosphorescent materials which show a decay in brightness less than 1 millisecond and fluorescent material where emission decay takes place over tens of nanoseconds. Phosphorescent materials are known for their use in radar screens and glow in the dark materials, whereas fluorescent materials are common in cathode ray tube and plasma video display screens, sensors, and white LEDs. Now we will discuss on resolution. It indicates the maximum number of points that can be displayed without overlap on the CRT. It is defined as number of points per centimeter that can be plotted horizontally and vertically. It depends on the type of phosphorus, intensity to be displayed, and focusing and deflection systems used in the CRT. Pixel energy distribution. Pixel density. The pixel density function is given by here DP indicates diagonal resolution in pixels, DI diagonal size in inches, W width resolution in pixels, H height of resolution in the pixels. Horizontal scan rate. It is the frequency at which a CRT moves the electron beam from left side of the display to the right side and back, therefore describing number of horizontal lines displayed per second. Bandwidth. More the bandwidth in a signal, more will be the visual resolution. Bandwidth is given by horizontal pixel times vertical pixel times pixel depth. Picture storage. Pictures are stored in pixels in a frame buffer which contains the intensity values of each pixel. Horizontal retrace. In a raster scan display, the electron beam returns electron beam to the top of left corner of the screen to begin the next frame. Interlacing. It is a description of how the picture is created. Here, the picture is created by scanning every other line and on the next scan, scanning every opposite line. It allows for a faster refresh rate by having less information during each scan at lower cost, but it may cause flickering. Picture storage for color and black and white images. A binary image, that is black and white image, can be stored in memory as a bitmap, a packed array of bits which contains 0 or 1 values in it. A color image can be stored in color map which associates a numeric pixel value with a color or intensity to be displayed on output device. In vector display, the image is composed of drawn lines rather than a grid of glowing pixels as in raster graphics. Advantages of CRT. The cathode ray tube can easily increase the monitor brightness by reflecting the light. They produce more colors. The cathode ray tube monitors have low price rate rather than LCD or plasma. The quality of image displayed on CRT is superior to LCD and plasma. The contrast features of cathode ray tube monitor are considered highly excellent. Disadvantages of a CRT. Disadvantages of CRT. They have a big back and take up space on disk. The electromagnetic fields emitted by CRT monitors constitute a health hazard to functioning of living cells. CRT emit a small amount of X-ray band radiation which can result in health hazard. Constant refreshing of CRT monitors can result in headache. CRT operate at very high voltage which can overheat system or result in an implosion. Within a CRT, a strong vacuum exists in it and can also result in implosion. They are heavy to pick up and carry around. Now we will discuss about color displays. Color tubes use three different phosphors which emit red, green and blue light respectively. Color CRTs have three electron guns, one for each primary color arranged either in a straight line or in a triangular configuration. Two techniques, shadow mask and beam penetration methods are used. Beam penetration method uses multicolored phosphor of number of layers, each phosphorus layer responsible for one color. A shadow mask tube uses a metal plate with tiny holes placed so that electron beam only illuminates the correct phosphors on the face of the tube. Here is a delta-delta CRT with a shadow mask and a black matrix. Limits on resolution. There are many limits on resolution and they are based on space, time, color and intensity. A plasma panel display is a flat screen display. Now we will see how a plasma panel display works. Two plates of glass are taken between which millions of tiny cells containing gases like xenon and neon are filled. Electrodes are also placed inside the glass plate in such a way that They are positioned in front and behind of each cell. The rear glass plate has with it the address electrodes in such a position that they sit behind the cells. The front glass plate has with it the transparent display electrodes, which are surrounded on all sides by a magnesium oxide layer and also a dielectric material. They are kept in front of the cell. When a voltage is applied, the electrodes gets charged and causes the ionization of the gas resulting in plasma. This also includes the collision between ions and electrons resulting in emission of photon light. The state of ionization varies in accordance to color plasma and monochrome plasma. For the latter, a low voltage is applied between the electrodes. To obtain color plasma, the back of each cell has to be coated with phosphor. When the photon light is emitted, they are ultraviolet in nature. These UV rays react with phosphor to give a colored light. Each pixel has three composite colored subpixels. When they are mixed proportionally, the correct color is obtained. There are thousands of colors depending on the brightness and contrast of each. The brightness is controlled with pulse width modulation technique. With this technique, it controls the pulse of current that flows through all the cells at a rate of thousands of times per second. Now, we are going to see light emitting diodes. An LED is a two-terminal semiconductor which emits light when activated. On supply of suitable voltage, electron and electron hole recombination takes place, leading to the release of energy in the form of photons. In an LED display, the diodes are set in an array for a video display. They are used in common transport vehicles and in signboards at few areas. Now, we are going to learn about organic LEDs, otherwise known as OLED. An OLED is an LED in which the emissive layer is a thin film or organic compound that emits a light when current is passed through. These are used to create digital displays in many devices such as TVs, mobile phones, etc. The biggest advantage of an OLED is that it's very thin and flexible. Now we will see the functioning of an OLED. To make an OLED light up, we simply supply a voltage across the anode and cathode. As the electricity starts to flow, the cathode receives electrons from the power source and anode loses them. Now we have a situation where added electrons are making emissive layer negatively charged, which is very similar to an n-type layer in a junction diode, while the conductive layer is becoming positively charged, similar to a p-type material. Positive holes are much more mobile than negative electrons, so they jump across the boundary from the conductive layer to the emissive layer. When a hole, a lack of electron, meets an electron, two things cancel out and release a brief burst of energy in the form of particle of light, a photon in other words. This process is called recombination, and because it's happening many times a second, the OLED produces continuous light for as long as the current keeps flowing. We can make an OLED produce colored light by adding colored filter into our plastic sandwich just beneath the glass or plastic top or the bottom layer. If we put thousands of red, green and blue OLEDs next to one another and switch them on and off independently, they work like the pixels in a conventional LCD screen. So we can produce complex, high resolution, colored pictures. Now, now we are going to talk about curved displays. These displays claim, these displays claim an immersive viewing experience, a feeling of being wrapped up by the picture. It sounds crazy, but this technology is the future of electronics. If we are going to find ourselves watching movies on cinema style curved televisions and chatting on shapely mobile phones, we should understand how it works and whether it advances this technology. Advancements in this technology have allowed for flexible materials to be used in products that were previously limited by rigid property of glass. Screens can be made in two ways. Curved screens are bent at subtle angle and flexible screens are able to bend back and forth to shift between the flat and curved. Behind the glass used in this technology is Corning, which has developed Willow, a thin, high performance flexible glass. Willow can conduct electricity and support LED and OLED color filters. The thinner the glass used, the more flexible the screens. These displays are introduced in 2014 by Samsung and LG. These screens have an optimum position for a better viewing experience. This optimal position is directly along the central axis of the TV with the central point of the screen at eye level. Viewers seated in any other position come to experience degradations in picture quality ranging anywhere from minor to severe, the most notable being trapezoidal distortion. Matrix addressing. This scheme sets the state of a pixel to either black or white. A display which is matrix addressed has control signals to rows and columns. If a screen has p by q pixels, the scheme would require p plus q control signals. There are two types of matrix addressing: active and passive matrix addressing, which are discussed later in the presentation. Now, we will look into liquid crystal displays. LCD, a liquid crystal display, is a technology used for displays in notebook and other smaller computers. Like an LED and glass plasma technologies, LCD allows displays to be much thinner than a cathode ray tube technology. LCDs consume much less power than LED and gas displays because they work on the principle of blocking light rather than emitting it. There are two types of LEDs: passive matrix and active matrix LED. Now, we will see how an LED works. We will now learn about the functioning of an LCD. It has a mirror in the back which makes it reflective. Then we add a piece of glass with a polarizing film on the bottom side and a common electrode plane made of indium tin oxide on top. A common electrode plane covers the entire area of LCD. Above that is the layer of liquid crystal substance. Next comes another piece of glass with an electrode in the shape of rectangle on the bottom and on the top. Another polarizing film at a right angle to the first one. On two pieces of polarized glass, a special polymer that creates microscopic grooves in the surface is rubbed on the side of the glass that does not have the polarizing film on it. The grooves must be in the same direction as the polarizing film. You then add a coating of pneumatic liquid crystals to one of the filters. The grooves will cause the first layer of the molecules to align with the filter's orientation. Then add the second piece of glass with polarizing film at right angle to the first piece. Each successive layer of TN molecules will gradually twist until the uppermost layer is at 90-degree angle to the bottom, matching the polarized glass filters. As light strikes the first filter, it is polarized. The molecules in each layer then guide the light they receive to the next layer. As the light passes through the liquid crystal layers, the molecules also change the light planes of vibration to match their own angle. When light reaches the far side of the liquid crystal substance, it vibrates at same angle as the final layer of molecules. If the final layer is matched up with the second polarized glass filter, then the light will pass through. If we apply an electric charge to the crystal molecules, they untwist. When they straighten out, they change the angle of light passing through them so that it's no longer matching the angle of the top polarizing filter. Consequently, no light can pass through that area of the LCD, which makes that area darker than the surrounding areas, hence the display. An LCD that can show colors must have 3 subpixels with red, green, and blue color filters to create each color panel. Now we will learn about matrix addressing. As we have seen earlier, there are two types of addressing, passive and active. Now we will be going into passive matrix. Passive matrix LCDs use a simple grid to supply the charge to a particular pixel on the display. It has two glass layers called substrates. One substrate is given columns and the other is given rows made from a transparent conductive material. This is usually indium tin oxide. The rows or columns are connected to integrated circuits that control when a charge is sent down a particular row or column. The liquid crystal material is sandwiched between the two glass substrate and a polarizing film is added to the outer side of each substrate. The row and column intersect at designated pixel and that delivers the voltage to untwist the liquid crystals at that pixel. The drawbacks are slow response time and imprecise voltage control. Now we will look into active matrix displays. Active matrix LCDs depend upon thin film transistors. Basically, TFTs are tiny switching transistors and capacitors. They are arranged in a matrix on a glass substrate. To address a particular pixel, the proper row is switched on and then a charge is sent down the correct column. Since all of the other rows that the column intersects are turned off, only capacitor at the designated pixel receives a charge. The capacitor is able to hold the charge until the next refresh cycle. And if we carefully control the amount of voltage supplied to a crystal, we can make it untwist only enough to allow some light through. Now we will see what is stereo imaging and what are virtual reality devices. Stereo imaging, it's a process of recording and reproducing the sound with respective perceived spatial locations of the source, both in lateral and depth. Virtual reality devices. Virtual reality is a PC innovation that utilizes programming created practical pictures, sounds, and different sensations to duplicate a genuine situation or a fanciful setting and mimics a client physical ambience to make the client to collaborate with the space. Now we will be dealing with a raster scan system. In raster scan systems, the electron beam is swiped over the screen one line at once from a start to finish. As the electron beam moves over every line, the beam intensity is turned on and off to make an example of lit up spot. Picture definition is stored in memory area called a refresh buffer or frame buffer. Every screen point is called as a pixel or a pel. Toward the end of every scan line, the electron beam comes back to one side of the screen to start showing the following scan line, which you can see in the picture on the right side of the sheet. This is the architecture of a raster scan system. In a raster scan display, the image which has to be displayed is saved in a binary format, that is zeros and ones, in the refresh buffer memory. Then, a video controller is used to scan each and every line of the refresh buffer memory. The lines are scanned from left to right, and when line is finished again, the controller moves to the next line and scans the line from left to right and so on. Then a frame buffer memory which holds the coordinates of all the screen points is used to determine the coordinates of the screen. After that, the actual image is produced in a cathode ray tube. Refresh operations from a frame buffer. The pixel intensities are stored in a register which are used to control the CRT beam intensity for a group of adjacent pixels. Now, it's time for some operations performed by video controller. They can retrieve pixel intensities from different memory areas on different cycles. In high quality systems, two frame buffers are often provided so that one buffer can be used for refreshing and other filled with intensity values. Provide the fact mechanism for generating real-time animation. Video controllers often contain a lookup table so that pickup value in the frame buffer are used to access the lookup table instead of controlling the CRT beam intensity directly. Display processor. It is also known as graphic processor or display coprocessor. Main function is to free CPU from the graphic cores. A separate display processor can also be provided in addition to the system memory. It digitizes a picture definition given in an application program into a set of pixel intensity values for storage in the frame buffer. This digitization process is called scan conversion. The functions of a display processor include generating various line styles, displaying color. Printhead has tiny nozzles which spray ink onto the paper. Printed document needs time to dry and it's quite impressive. Electrostatic printer. Electrostatic printer. Electric charge is first used to write pattern. This pattern is brought into contact with pigment with charge of opposite polarity, thus focused onto the paper. Second method, charge is applied using styluses. Let us look into electric static printer a bit more. Here, image is first written as a pattern of electrostatic charge and is then made visible by bringing the pattern into contact with particles of pigment that carry a charge of opposite polarity. The pigment is only attracted to charge pattern and hence fuses to the paper. Second method, as we have already mentioned it, the stylus thermal printer, a digital printing process where thermal paper is selectively heated. The heated area turns black, creating an image. Now we will look into principles of 3D printing. Manufacturing complexity is free. Same cost for simple and complex objects. Cost includes time and skill. No extra cost for the complex items. Variety is free. Like a human artisan, a 3D printer can fabricate different shape each time, unlike traditional manufacturing machines which are much less versatile. No assembly required. 3D printing from interlocked parts, mass manufacturing is built on background of the assembly. Zero lead time. A 3D printer can print on demand when an object is needed. The capacity for on-spot manufacturing reduces the need for companies to stockpile physical inventory. Unlimited design space. Traditional manufacturing technologies and human artisans can make only finite shapes. A 3D printer removes these barriers, opening up vast new design spaces. Zero skill manufacturing. Traditional artisans train as apprentices for years to gain the skill they need. A 3D printer gets most of its guidance from a design file. Compact and portable manufacturing. Less waste by product. 3D printers that work in metal create less waste by product than do traditional metal manufacturing techniques. Types of 3D printing. Stereolithography (SLA), built using stereolithograph apparatus, uses polymers, converts liquid plastic to solid 3D objects. Objects that are built will have smooth surfaces. Digital light processing. Process involves digital micro mirrors on semiconductor chip, uses polymers, SLA and DLP, use different sources of light. Liquid crystal display is applied to resin container. It hardens quickly when exposed to large amounts of light. Fused deposition molding. produces excellent quality thermoplastics used to build conceptual models and final end use products that are used in high performance engineering. Software cuts CAD model into layers to estimate the way it has to build. Printer heats thermoplastic and extrudes it through nozzle. Selective laser sintering. It's very similar to SLA, but SLS uses powered material in vat instead of liquid resin. Doesn't need any support structures. Wide variety of materials like nylon glass, ceramics to aluminum, steel or silver can be used. Selective laser melting sources 3D CAD data, builds layer by layer, high power laser beam fuses and melts metallic powder together. Used in parts with complex geometrics and structures with thin walls. Electronic beam melting uses power bed fusion technique. SLM uses high power laser beam whereas EBM uses electron beam. Slow and expensive. Availability of materials is limited. Laminated object manufacturing. Layers of adhesive coated paper, plastic or metal laminates are fused together using heat and pressure and then cut to shape with a computer controlled laser or knife. Post processing of 3D printed parts includes such steps as machining and drilling. Graphic software. Overview of graphic software systems. General programming package. A general programming package provides a library of graphic functions that can be used in a programming language such as C, Java, Fortran. Designed for programmers. Example graphics library. Special purpose application package. User interface is typically a set of menus, programs. Prior knowledge of graphic procedure is not required. Designed for non-programmers. Various coordinate systems. There are many coordinate systems: Cartesian coordinates, modeling coordinates, world coordinates, normalized coordinates, and device coordinates. The respective functions are mentioned in the PPT for you to look up. Graphic functions. A general purpose graphics package gives clients an assortment of functions for making and controlling pictures. These functions can be comprehensively grouped by the way they manage design yield information. Input or output functions, subdividing pictures, or general control of transformations. Types of PF graphic functions. Control function, IO function, modeling function, viewing transformation, object rendering, output primitive. And here is a sample program with the comments given below so that you could look into it and get a clear understanding of the program. References for making the PPT are listed here in this.